Good afternoon, everyone. Thank you very much for joining our webinar. This is part of our webinar series we are calling Data to Intelligence. We're going to be doing a series of webinars on this topic where we'll talk about how to build AI applications on top of your data, how to secure your data that feeds AI, and various related things. Today, we're going to focus specifically on building an agent. What I want to start with is setting a definition of an agent. I know this is probably a little bit overused, but the general definition, at least for this conversation, is that we have an application that is driven by a large language model that has access to certain tools, and the large language model makes decisions on when to use those tools, how to use those tools, if necessary, in a loop to achieve a specific goal. That's what we are calling as an AI agent. These tools could be something like fetching data from a database, sending an email or a Teams message, or creating a document. Again, these could be any of the APIs that we expose to a large language model for it to accomplish a specific goal. Now that we defined an AI agent, we'll just give a high-level overview of what does it involve in building an agent. So typically, the first step in building any AI agent is to establish a unified data platform. This is where you want to make sure all of your different data sources are aggregated into a single place where you can set up some strong governance and security. And then the second step is to clean up that data, make sure it is of highest quality. Again, data is the fuel for AI. So if you don't have good data, then the results from AI will not be that great. So once we do these two steps, then the final step is to build generative AI applications on top of this data platform. This is where you will use large language models or small language models and tweak the data as you need it so that you get the best experience out of your generative AI applications. Now, obviously, there are several tools to help you go through this journey. Today, we are going to focus on two of them, Microsoft Fabric and Microsoft Copilot Studio. We're going to take a quick poll to see how familiar the audiences are with these tools. Rebecca, if you can launch our polling questions. So the first question is around how you all are using AI today. What kind of applications are you using? What kind of governance you have any, if any? We just want to get a pulse on how familiar you guys are today with some of these tools. It looks like a lot of people use Copilot, ChatGPT, or Claude with IT approval. That is a good start. That's very nice to see. And we have about 20% of people still who have built custom agents. So that's really nice.
Another second or two on this one, and then I'll share the results. A couple more coming in. All right. All right, then we'll go to the next poll.
Yeah, this poll is just to see how much you all know about Fabric, just so that it will help me whether I should stress on some of the features in Fabric or not. Okay, looks like at least half of you are with some familiarity with Fabric. That's nice to see. We'll just leave that poll open for a few more seconds.
Go ahead and close it.
Okay, yeah, around 70% of you have heard a little bit about Fabric. That's nice. Okay, like I mentioned, we're going to focus on Fabric and Copilot Studio to help us go through this journey of building agents. Now, agents are not all created equal. They do exist on a spectrum from simple to most complex. On the most simple side, we have something that is a simple retrieval agent. This is something that is searching your documents or your data and answering basic questions around it. Again, you have to ask a question to get an answer. So it's a better search engine for the most part. A step up from that is something that can perform certain tasks on your behalf. You're still prompting the agent to do something such as sending an email or summarizing a document and things like that, but it's still focused on a specific task. So not too complex, but we are increasing a little bit from a complexity perspective compared to the retrieval agents. And on the far end of the spectrum are much more autonomous and dynamic agents that can continuously monitor your environment and take actions. They don't necessarily wait for a prompt from a user. They have their own independent identity. They don't necessarily always act on behalf of a user, but sometimes they do. But they make decisions somewhat independently out of a human. So that's the most complex side. When we're talking about agents, just try to remember that the complexity varies depending on your use case. So for building agents, there are several options. On the far left side, for the most simple agents, you can use off-the-shelf products such as Copilot, Claude, ChatGPT, give them access to your documents, and they can answer questions based on those documents. With apps like this, there is not much control you have as a user on the quality of the output, but it can get you some basic help in terms of searching through large documents. And a next step up from that is using something like a Copilot Studio, which is a low-code tool or a platform that will help you build agents. You have a little bit more control or diversity in exposing your data set to these agents, not just static documents. You can use some of the tools available in Copilot Studio to connect your databases or other data sources. Still, you don't have full control on the quality of the output, but you start getting a little bit more control over the quality of the output, how to secure the access that these agents have. And from then, you can step into writing more code solutions. So far, you have up until this Copilot Studio option, there is not much code being written. But from now on, the more code you write, then you get more control over the quality of the output, over the format of the output, how you want to instrument these agents, how you monitor them, how you control access to them. That's where you start writing more and more code. You build your own custom orchestrator if necessary. You have things like MCP servers, the Model Context Protocol servers that allow you to expose much more data sources. And on the far end of the spectrum are the full enterprise grade platforms, where you are now fully into the pro code environment with its own lifecycle, application lifecycle, where you have strong governance and gates on when you publish an agent into production. You have staging areas where you go through dev, QA, and ultimately to production environments, these agents. So that's the most complex, where you write more code, whereas on the towards left-hand side, you write little or no code. Typically, we would recommend to start with something like a Copilot Studio, where you can quickly validate your use case and then start refining it so that you can slowly move into the pro code area or write MCP servers as necessary and tweak it to improve the output of your AI application. So for this conversation, we are going to use a sample agent that we have built internally. This is our sales opportunities agent. At ProArch, we track all of our sales leads in two systems, HubSpot and a custom ticketing system. So far, it's been a little bit challenging to consolidate the data from these two systems and get a comprehensive view into our sales pipeline. So what we did is to build this agent where instead of relying on a two-dimensional report, Power BI report, where we are relying on an LLM to gain some real-time insights and make decisions faster so that we can see which sales leads are falling behind, getting cold, which ones we have to allocate more resources to increase the probability of win. To achieve this, we are using Microsoft Fabric as our data platform, and then we have built an agent using Copilot Studio. I'm going to walk you guys through how we built this, what is the architecture, and what are some of the lessons that we learned in building this agent. I'm going to switch to a brief demo to show you guys what exactly this sales opportunities agent can do. So give me a second while I switch my screen. If I can figure out how to switch my screen. There is my PowerPoint. Oh, okay. All right. So now I want to go to my Fabric first. I'm assuming you all, Rebecca, can everybody still see my screen?
Yes, all
okay.
good.
Okay, all right. So this is our Fabric environment. I want to briefly describe what our database looks like as we built this. So we have few tables, nothing major complex here. The opportunity table is the main table for our sales pipeline. This is where we have all of our actively pursuing sales leads, the name, the company that it's associated with, the contact information, the state, whether it is active, closed, won, lost, the business unit that it belongs to, the value of this opportunity when it was created, and few other fields. In addition to this opportunity table, we have some related tables. Account executive table is the table describing the executives that are pursuing those sales leads, their name and contact information. Similarly, the company, the customer that those sales opportunities are related to, that's in the company table, and some of our other sales folks that are associated with these leads, those are the different tables. So here I have a query. I'm going to zoom in a little bit, where I am asking to give me a summary of all the opportunities that are created in 2025, but grouping them by the business unit. We have 4 business units. I just wanted to see in 2025 which business units generated the most opportunity value in 2025. So you can see out of the 4, we have industry solutions ranking high with 28 million. So this is the data set that we have. Normally, we would have created a Power BI report, but that is just static 2-dimensional data. What we wanted to do was have much more dynamic conversation using a natural language interface. The Copilot Studio agent that we built, we have been able to publish it into Microsoft 365 Copilot. So here you can see that's one of the different agents that I have built. This is one of them. And I have asked it a question that I just showed you about the SQL query. I'm asking it to rank all business units based on their performance in 2025. And it's gave me this answer where it is showing me the same values. Industry solutions is ranked number 1 with 28 million, digital engineering with 9 million, and so on and so forth. But the most important thing is this section, because we have provided in our instructions to the agent to draw some insights into this data. It's able to tell me quickly which business unit is performing better and which business unit is lagging. So this is a different view of the data, much more natural language, and it helps people to quickly gain that insight and make a decision on. Now so I just want to give you a brief overview of what the end result will look like. This is the agent that we built. So now I'm going to switch to the slides and I'm going to walk you guys through what all we did to build this. So I'm going to switch to my PowerPoint back here. Typically, in an enterprise, our data estate is somewhat siloed. We have multiple vendors. The interoperability between these systems is not that great. It's a little bit challenge to enforce consistency in terms of security or governance. So these are all the challenges that we typically see in an enterprise, especially medium to large enterprises where there are multiple teams that manage different products and different data sources. Ideally, what we would like is our data estate to look something like this. We would want a unified data foundation where all of our data from different systems is ingested into a central place where we can put a strong governance and security around it. We can do some data engineering around that data where we can slice and dice that data, prepare it for our analytics. If there is real-time data, we want to get real-time insights on that and prepare this data for machine language and AI apps. This would be the ideal way. Every organization aspires to build this. It's not easy, but this is what the ultimate goal is for every enterprise. And Microsoft Fabric is one of those tools that brings us very close to this foundation, building this unified data foundation. What it allows is it has a strong data pipeline framework where you can bring in data from multiple data sources into one single place. It has built-in security mechanisms so that you can enforce a strong data governance and security for your data. Make sure your sensitive information is not leaked to or it's exposed to unauthorized access. And with the tooling available in Fabric, you can establish end-to-end visibility on who is accessing the data, what data is coming in, what data is flowing out. And generative AI is very built into this Fabric platform. It's not something that is an add-on piece. It's just a native feature inside Microsoft Fabric. How does Fabric achieve all of this? There are multiple types of workloads. So like I mentioned, with the data factory pipelines, you have hundreds of connectors to ingest data from multiple data sources. You can build lakehouses and warehouses to support your analytics workloads. You can even do Spark workbooks that are native to Fabric. So you can massage your data, do some data engineering tasks. You can even set up operational databases if you wanted to, whether it is SQL or NoSQL databases. I think right now there is support for SQL Server, Postgres, and Cosmos. Those are the three types of databases that are available natively in Fabric. If you have a real-time data stream, whether it is IoT data or things where you capture information on a per second, per minute interval, then you can set up those real-time pipelines to get active insights in real time for your data. Your Power BI visualizations are now part of Fabric as well. So all of this data that you have aggregated, you can build beautiful visualizations using Power BI. And one of the new components of Fabric that Microsoft just announced, it's called IQ. This is what makes building AI applications much more easier. This is a collection of semantic models of your data, ontology of your data, knowledge graphs of your data. All of this is part of this IQ workload, which makes it easy for large language models to understand your data, the relationships between your data, so that it can give you better answers. Copilot is part of this Fabric platform throughout the workload. So you can leverage AI to make your tasks easier, be more productive in Fabric. For example, if you have a Power BI report, you can have Copilot answer questions in natural language about the particulars of that visualization without drilling down deeper into the data. Copilot makes it easy for you. All of these workloads, they don't duplicate data. They all act on a single copy of data that's stored in one lake, which supports open data formats. So there is compatibility with other non-Microsoft tools such as Databricks or Snowflake. So if you have data located in those platforms, then Fabric interoperates with them very easily so that you don't have to duplicate the data, but still gain advantages out of the features out of Fabric. Microsoft Purview is another product that plays very well with Fabric. That's what allows you to build your data governance and security. So if you have a particular data labeling mechanism or data cataloging mechanism, then Purview makes it easy to implement all of those features and establish that data governance. I want to touch a little bit about the security in Fabric. Obviously, role-based access control is native to Fabric. It integrates with Microsoft Entra ID. So you can use your Entra groups to control permissions to different items in Fabric, your lakehouses in warehouses. And not only at the item level, you can go one level deeper where you can set up granular security either at the row level or the column level, or even if you want to mask data. For example, if you have sensitive fields like social security numbers, you want only the last 4 digits displayed by default or to specific roles, then you can set those policies very easily in Fabric. The tooling that's available in Fabric gives you a lot of audit logs so that you can track every single user activity. That makes it easier for to meet your regulatory requirements, PCI or other regulatory requirements. They become easier with the tooling that's available in Fabric. All the data that's stored in Fabric is encrypted by default, but if you wanted to customize that encryption with your own managed keys, then you can do so by integration that's available with Azure Key Vault. So this Fabric covers the first 2 steps of our journey. If you remember the 3-step journey in building AI agents, the initial portion was about building your data platform and establishing a governance and security process for your data. So Fabric helps you up until that point. Now we have our data platform. We have established some security and governance rules. So now we are ready to build our AI applications or AI agents. So what we will now talk about is one of the tools for building such agents, a Copilot Studio. Copilot Studio is a low-code, no-code platform. You can build agents by simply describing what you want that agent to do, or you have a configuration screen where you can tweak each setting to customize the behavior of your agent. What Copilot Studio provides is a runtime so that you can publish your agent into multiple channels. You can set up some triggers, such as maybe you want the agent to react when a particular email is received or for a particular message in Teams channel. So you can set up similar triggers like that. You do get a full application lifecycle management where you can promote your Copilot Studio agent from QA environments to production. You have some telemetry as well to know what sessions users are using within the agent, how the agent is responding to those questions. You have a lot of tools and integrations to connect to different data sources And all of this integrated with Entra ID security by default. So you can control who has access to what agents and how they can interact with the different data, so your own enterprise data sources. The other good thing about Copilot Studio is that it understands different languages automatically. So you can have one agent switch between English and Spanish, for example, very easily. It's easy to build multi-language agents using Copilot Studio. A typical process for building Copilot Studio agent would look something like this. So the very first decision that you would have to make is to decide where you want to publish the agent. Would this be available in 365, your M365, or Teams, which is the default option, or you can publish it to SharePoint, custom website, native app, so on and so forth. So once you decide the channels, then you want to decide what knowledge sources or what data sources you want to give access to for this agent. There are two ways to do this: knowledge sources and tools. Knowledge sources are things like SharePoint files, internal websites, documents, PDFs, and words that are somewhat semi-static in nature. That would be your knowledge sources. Things that are much more dynamic, whether it is your operational databases or analytical databases. You have a lot of connectors that will allow you to connect to those data sources. So once you give the access to those data sources to this agent, then it will be able to answer questions based on the data that it retrieves from those data sources. Then a couple of other optional steps are for you to decide if you want to orchestrate a flow where you can build multiple agents and they all can work together as one automated flow. So there is an agent flow concept within Copilot Studio where you can orchestrate multiple agents. Or you can say a specific topic should be handled in a specific manner. That where if somebody says, hey, I have a question about my invoice, then you can trigger a flow that is very specific to invoice. Maybe it verifies a few pieces of information about what kind of invoice, what is the invoice number. So all of that logic can be grouped into a conversation topic, so that when somebody talks about invoices, then that topic executes the flow that you have set up. So this is a high level overview of how you build an agent using Copilot Studio. Now we'll talk a little bit, few more details about some of these things. As I mentioned, there are multiple channels available for publishing agents built using Copilot Studio. Teams and Microsoft 365 are the default options, but you can build custom web applications or publish it to your SharePoint app, Facebook, and several other options, as you can see here. I talked about the knowledge sources. So with the power of knowledge sources, building RAG chatbots is very easy with Copilot Studio. You don't write a single line of code. You just point your Copilot Studio to your document source, whether it is in SharePoint or just PDF Word documents that you can directly upload into Copilot Studio. You can even tie it to Azure AI Search, which is a feature within the Azure AI Foundry platform where you can build your own custom vector storage for your all of your documents that are indexed. You can connect that as well if you wanted to. It does have support for searching public websites as well. That way it can retrieve information combining public internet along with your internal documents. So that makes it very powerful and easy to build a RAG chatbot very quickly with Copilot Studio. In addition to knowledge sources, another way to give access to your internal data is through tools. Copilot Studio is built on top of Power Platform, so all the connectors that are available in Power Platform, Microsoft Power Platform, are available in Copilot Studio as well. So that gives you hundreds of data sources, Snowflake, Oracle databases, almost every single Postgres, every single type of database that you can think of. There is a connector out there for it. You can use those connectors. If you have REST APIs, there is a generic REST API connector. It has strong support for Model Context Protocol, which is an open source protocol that provides some guidelines on how large language models should interact with external tools. There is also a computer use tool, which means if you have a desktop application that where there is no REST API, then your Copilot Studio agent can invoke your mouse and keyboard and interact with that desktop application. So that's also one of the tools available, which gives you a lot of flexibility in building fairly complex agents using Copilot Studio. For our conversation, we're going to focus on using MCP tools. I just want to give a brief high-level overview of why MCP is powerful. Normally, a large language model, when you ask it a question, it answers based on the data that it was trained on. So whatever data it had access to during its training, that's the only information that it can respond to. The real power comes when we combine this large language model with some connectors. That is where we are giving it access to our enterprise databases, for example, SQL Server or Oracle Server or Snowflake, things like that. Now, obviously, in each enterprise, there are multiple systems. So custom coding and integration every single time a new data source has to be connected, that makes it cumbersome, and it opens up for a lot of security implications where maybe there is not a standard way all of these tools are connecting. So to address those challenges, that's what MCP protocol does, address all of those challenges, where it provides a standard protocol on how large language models should interact with external tools. So if you expose your APIs or your data sources using MCP protocol, then large language models, whether built your AI applications built using Copilot Studio or Claude or ChatGPT, they all know how to use those tools. Excuse me. So that's what makes MCP very powerful and allows to bring a standardization around how AI uses our enterprise data. So what I will do is I will talk through some of the design aspects of our sales opportunities agent, which is what we are using as an example to demonstrate some of how we implemented some of these concepts. What we have are two systems, HubSpot and a custom ticketing system, where we track all of our sales opportunities. Every time we have a sales lead, we create tickets and we log some information into HubSpot. So what this means is that there is no one unified view of the end-to-end life cycle of a sales lead. So what we did is we built a data pipeline and built aggregated data from both HubSpot and our ticketing system into Lakehouse in a Fabric. And then we exposed that data, our Lakehouse data, through a GraphQL API, which is again a built-in feature of Fabric. We didn't have to write any code for this. So what we were able to achieve with this is a REST API for our Lakehouse data. Then we built an MCP server with Entra ID authentication that can execute some GraphQL queries against this Lakehouse using that GraphQL API. Now that we built this MCP server, we then connected it to our Copilot agent, where we told it this is the MCP server that you want to use to answer questions about sales opportunities. So whenever a user prompts our Copilot agent, if they are authenticated with Entra ID using OAuth, and that token is then passed to MCP server, So for whenever the Copilot Studio agent invokes the tools exposed through MCP server. This is a sequence diagram of that interaction. You can see at the very top, the user sends a prompt to the Copilot Studio agent. The agent processes that question. It figures out it needs to invoke a tool from the MCP server. It first makes sure that it has the token from the user from Entra ID, which then it passes to MCP server, that access token. The MCP server, which then exchanges that access token with Entra ID to get a new token for invoking the Fabric GraphQL API. Why this is important is because this way we are able to maintain the user context all the way throughout this pipeline. So the user that is logged into Copilot Studio agent, we are executing the GraphQL query under his token. So that's what makes this access secure instead of using a service principal in the MCP server where all users are proxied as one single user. We are maintaining the user identity throughout the chain, so that way we can ensure whatever data security rules are set up on who has access to what data, those are still maintained even when we are interacting with the data through the Copilot Studio agent. So once the MCP server obtains a new token, it invokes the Fabric API, the GraphQL API, retrieves the data set, sends it back to the Copilot Studio, which synthesizes those results and presents the response back to the user. So here is a brief demo of what we saw earlier. So here I'm asking, give me a breakdown of all the opportunities created in Q2 2025 by business unit. You can see I have not used the word business unit, but I used our internal abbreviation BU, but the agent was still able to understand that. I'll show you how we were able to do that with the system prompt instructions in a second. So it fetched the data. It is showing me in a tabular form and providing me some insights into which business unit is dominating, which business unit is lagging, and so on and so forth. So how exactly did that fetch that result? So what here is a activity overview of what actually the agent did. When I asked the question about opportunities created in Q2, what the agent did is it invoked a couple of tools available in my MCP server. The first one is the introspect schema, where it understood the relationships that exist between the different tables, what are the columns that are available. So it gained a basic understanding of the schema of my lakehouse. Then it formulated a GraphQL query. You can see I only specified Q2 2025, but it translated that automatically into the date range for the created on field. And even in the query, you can see here, it's aggregating based on the business unit because I asked it to show breakdown by business unit. What I'm going to do now is switch to Copilot Studio and show you guys some details on how we have set up Copilot Studio to achieve this result. So this was my Fabric Lakehouse. So here is my Copilot Studio interface. This is my agent, the name, description. You have several large language models to choose from. GPT-5 is now generally available. It was only recently made generally available, but you can use Claude models as well. So you get to choose which large language model you want to use. And it's generally preferable for you to experiment with a couple of models. Different models perform differently for different tasks. So you want to see which one gives you the best performance. Keep that in mind to play around with a couple of these options to figure out which one gives you the best results. I'll go through this. This is where you specify your system prompt. I'll show this to you guys in a more detail. I have it here in this markdown view where we first describe what the purpose of the agent is, what its core capabilities are, and I have also given it a dictionary of terminology. In one of my prompts, I have used the term BU, which is not necessarily a standard for business unit, but because of the instructions where I have described what terminology my users typically use, the large language model is able to understand that. I have also provided some descriptions of what tables exist in the database to help the LLM make those query decisions quickly. I have described what tools to use inside MCP, when, under which circumstances each of those tools should be used. There are some Power BI reports that are available as well. I have given instructions on how to fetch those visualization links. And I have given it some additional rules on how to formulate the GraphQL. What are the rules that it should follow? Where I have said, always pull 500 records indicate that the paging size should be 500, because otherwise in Fabric GraphQL, the default is 100. So depending on the data set you have, that may or may not be the optimal. So these are the pagination rules that I have specified. And the most important part that made a real difference are these query examples. Large language models learn a lot more quickly with examples than just paragraphs of text. So in our testing, giving examples like these queries made a lot more difference in the LLM formulating correct and more efficient queries. Otherwise, what it would do is it would form a query that it would run into errors, and then it would try to adjust it again and again. So it was not that efficient. Giving some examples made it where 9 times out of 10, it generates a much more accurate or much more efficient query. So that is something to keep in mind, where examples do become important for your system prompt. I have also given some guidelines on how to format the response, when there are many items, when there are fewer items, how to display the results. And I have also given some guidance on how to handle the errors. Again, it's not possible to eliminate the errors. A large language model will sometimes generate a wrong query. So it is important for you to include in your system prompt instructions on how LLM should react when it sees that error. In this case, we are asking it to parse the error message and regenerate the query to fix that error message. One other thing that I would like to show is the security, how we took advantage of the row-level security or the role-based security in Fabric, and how we propagated that through the Copilot Studio agent. Here, I was logged into Fabric as an administrator, so I have access to everything. That's why when I asked for the 2025 data, you can see it gave me $28 million for Industry Solutions business unit. What we will do now is I'm going to log in to Fabric as an account executive. The way we set up this lakehouse is that we set up permissions where when an account executive logs in, he or she can see only their sales leads. They cannot see other account executives' sales leads. So when I execute the same query that I have previously executed as administrator, when logged in as a different user with a limited role, of the account executive role, you can see the numbers are different. This particular account executive, for his 2025 opportunities, digital engineering is the leading business unit with 4 million, and industry solutions with 311,000, and cloud and infra 97,000, and so on and so forth. So you can see the difference between an admin who has access to everything and a limited role that has access to only few records in that same table. So this is achieved through that row level granular security that we have implemented in Fabric. Now, as I showed in my architecture diagram, we are using Entra ID authentication tokens with something called on behalf of user flow, where we are executing all the GraphQL queries as if under the user's identity. So if I log into M365 as this particular user and ask the same question, rank all business units based on their performance in 2025, you can see it gives me the same answer or the same numbers that I have seen in Fabric. 4 million for digital engineering as the top unit, whereas if I go and execute the same question as an administrator, I get a different result because I have access to all the data records, whereas this particular user has access to only records he can see, which in this case are the sales opportunities that he's working on or he worked on in 2025. Another topic that I would like to touch on is observability. Copilot Studio has agents built in Copilot Studio can be integrated into Azure Application Insights. So that allows you to gain full visibility into what the agents are doing, what questions people are asking into the agent. So in this case, you can see the question I have asked earlier in the day. So I can see exactly the conversation that happened, and you can see what we have did with our MCP server is to instrument that with the same Azure Application Insights function string. So we are logging what tools are getting invoked by which user in each of those sessions. So you can see the account executive one invoked this introspect schema tool, and then the query GraphQL tool got invoked, and then the response back from the LLM that was based on that data. You can see all of that in Application Insights. So this gives you lot more visibility into what your AI apps are doing, what data they are accessing, who is accessing what, so you can have an audit trace of what is going on with your application, AI applications. So let's talk about some of the best practices that we have learned in this journey. I'm going to start off with the Copilot Studio agents. One thing that is clear is you want to start with simple instructions and then iterate over them again and again until you improve the accuracy and consistency of the LLM responses. So it's not going to be a once and done type instruction. You have, just like everything else, you have to iterate over it. And over time, as you iterate it over it, you will see an improvement in the performance when it comes to accuracy and consistency. And make sure your instructions are grounded in the tools and knowledge sources that you have given access to. Do not refer to items that are not available for the agent. So then it's not going to be able to give you good results if you refer to things that it doesn't know what to do with. There should be clear guidance on the response format, excuse me, and the constraints on how much content it should display or what format it should display. All those things should be clearly defined. Use the accurate names for your tools. I think I missed this portion. Let me go back to Copilot Studio for a second. So we have in the tools section, here is where I have configured my MCP server. And you can see all the tools that are available exposed by that MCP server automatically populate here. You would want in your instructions, you would want to use the same exact names of these tools. That's what makes a much more meaningful impact than just a full description when you refer to these tools in your system prompt. And another thing that is important is to specify when each tool should be used so that LLM has the guidance on when to pick, under what circumstance it should pick some of these tools that you have made it available. Using Markdown for your system prompts rather than just one continuous paragraph is another best practice. It is typically all large language models are trained in Markdown format. All the documentation, the internet data sources that they get access to, that's all formatted using Markdown, and that's what is used for their training purposes. So they understand Markdown format a lot more clearly. So you start using Markdown format for your system prompts as well. And the other biggest thing is to include examples for the usage of the tools. That in my case, I had given examples of how to build GraphQL queries for different scenarios. That's what allowed our agent to produce much more accurate results and more efficient queries rather than simply relying on LLM understanding the schema and figuring out how to form the queries. The next topic would be around building MCP servers. So these are some of the observations and best practices that we have learned over this exercise. Think of MCP servers as a microservice within a specific bounded context. So they are somewhat similar to your REST APIs, but they are not exactly REST APIs, but they are a microservice with a specific purpose. And also each tool within the MCP server should have a single responsibility. And there should be enough distinction between the different tools that you expose through your MCP server. Otherwise, if a couple of tools are somewhat close in functionality, then LLMs will not make a good choice in picking the right tool. So you want to make sure in your description and your inputs and outputs, the tools within MCP server have enough distinction so they maintain a single responsibility, just like how it is a best practice with writing code. The same principle applies here. Pay attention to error handling. Make sure the error responses from your MCP server include as much information as possible so that LLM can learn from that error message and tweak the execution of its query. Again, you don't want to reveal too much sensitive information in those logs, but you do want your error messages to be meaningful so that the LLM can interpret that error message and understand what it needs to do differently to get a successful response. From a security perspective, do not trust any input coming into your MCP server. Validate all inputs, even though the large language model is forming that input. You don't want to trust that. You want to validate it, just like you would validate any REST API inputs that come from any of your other applications. OAuth MCP servers have strong support for OAuth protocol. So you want to use that as your authentication mechanism where you have clearly defined scopes so that you can even scope at either the MCP server level or maybe even at the tool level, depending on your use case. Instrument your MCP servers just like any other API. In our example, we instrumented it with Azure Application Insights, allowing us to figure out which session invoked which tool, what was the input that was sent, and what was the output that was sent back from MCP server. In certain cases, caching might be appropriate, so you would want to think about that. What caching helps is improve the performance on your agentic side, where instead of waiting for the query execution, it could probably, if it's the same query from the same user, it could prefetch from that cache. Design your MCP servers for async pattern. Again, in all of these cases, you are accessing your enterprise data sources, which means you have some kind of IO intensive operation. So remember to keep your MCP calls follow the async pattern. So those are some of the lessons. If we just to recap, building agents is a journey, and the very first step and the important step is to build a data platform where you have strong governance and security, and then building your AI agents on top of that data platform makes your AI journey a lot more easier and helps you get higher return on investments, because as if you don't have clean, good data, then you don't get good results from your AI applications. Thank you, everyone.